Welcome to this explainer. If you've ever sat in a microbiology class and wondered how all that textbook theory actually translates into massive real-world industrial production, well, you're absolutely in the right place. Today, we're bridging that massive gap between academic theory and industry-ready lab skills. We're going to analyze a specific curriculum designed to get you completely bench-ready.
So we're looking at this exact training flyer from Genomia Diagnostics Research. It maps out a comprehensive path to mastering practical skills in industrial microbiology. We're going to break down this visual roadmap step by step to see exactly how a professional training sequence is structured to take a student from handling tiny microscopic samples to running massive bioreactors.
Here's our agenda. We'll kick things off with the Industrial Microbiology Advantage, then move straight through Week 1, Culturing and Isolation, Week 2, Shake-flask Production, Week 3, Fermenter Operations, Week 4, Analysis and Reporting, and finally wrap up with practical activities and assessment. Let's get right into it.
Section 1. The Industrial Microbiology Advantage.
What's really fascinating here is the clear promise Genomia makes right out of the gate. They're offering a super condensed, one-month certification program that explicitly combines theoretical knowledge directly with hands-on training. I mean, let's be real, in the sciences, theory alone just isn't going to get a commercial fermenter running. This structure pairs what you know with what you can physically execute, packing a huge amount of practical upskilling into just 4 weeks. It's all about bridging that gap between simply understanding a microbe's metabolism and actually keeping it alive in a giant steel tank.
Moving right along to Section 2, Week 1, Culturing and Isolation.
The flyer lays out this brilliantly explicit week-by-week plan. Just look at how the program builds momentum chronologically over the 4 weeks. You aren't just tossed into the deep end right away. There's a very deliberate, staged progression starting from micro-level handling in Week 1 all the way up to industrial-scale operations and data analysis by Week 4. It's a perfectly logical flow from mastering incredibly complex living systems.
So we start by unpacking the first critical learning outcome, mastering aseptic culturing and pure culture maintenance. And guys, the stakes here are incredibly high. Think about it. If your initial culture is contaminated by even a single rogue airborne spore, every subsequent step in your industrial process is going to fail, potentially ruining thousands of dollars worth of materials down the line. Because of that, Week 1 is entirely dedicated to the foundational and honestly notoriously difficult skill of safely handling, isolating, and keeping microbial cultures completely pure. It is absolutely the bedrock of industrial microbiology.
Section 3, Week 2, Shake-flask Production.
Now, the crucial concept here is inoculum preparation. You can't just drop a microscopic amount of bacteria directly into a massive industrial tank and expect great results. They'd be completely overwhelmed. Inoculum preparation serves as the exact vital bridge between your tiny, pure Week 1 culture and those upcoming large-scale systems. You're essentially growing your microbial army to a sufficient size and strength so they can actually handle a much larger, way more stressful environment.
Connecting this directly back to the learning outcomes, Week 2 is where students truly start generating actual production volume through shake-flask production. It's an exciting phase, right? Because theoretical growth finally translates into measurable physical volume. By constantly agitating or shaking these flasks, you dramatically increase oxygen transfer and nutrient mixing. You're expertly managing the environment to encourage rapid, healthy replication.
Section 4, Week 3, Fermenter Operations. Okay, the training wheels completely come off here. The learning outcomes specifically demand that students master the physical setup of the fermenter right alongside the precise control of its operating parameters. This definitely isn't passive observation. You are learning to pilot the actual core machinery of the biotech industry. Understanding how to calibrate the temperature, inject the exact right amount of aeration, and set the agitation speed to mix the broth without physically shearing your microbes apart with the impeller blades, well, that is exactly what separates an academic student from a highly paid industry professional.
Section 5, Week 4, Analysis and Reporting.
A major learning outcome mapped out on the source document requires you to explicitly compare the performance data from your Week 2 shake-flask runs directly against your Week 3 fermenter runs. This is absolutely fascinating because it teaches you about scale-up dynamics. Does the microbe perform differently in a small shaking flask compared to a highly controlled, massive fermenter under tremendous fluid pressure? Answering that question and predicting those differences is the very essence of process engineering.
To do that comparison effectively, you have to rigorously record your observations and analyze the process data. This is highlighted as a specific learning outcome
because it's just an irreplaceable skill in any professional laboratory. The industry doesn't just want scientists who know how to turn on the machines. They desperately need professionals who can interpret the resulting data, spot hidden inefficiencies, and scientifically report on the outcomes to optimize the entire manufacturing pipeline.
Section 6. Practical Activities and Assessment. Take a close look at this assessment breakdown from the flyer. Notice how practical, hands-on skills like fermenter operation and sampling and analysis are weighed equally alongside professional attributes like lab discipline and your ability to clearly communicate findings through a mini-project and final presentation. It's a truly holistic assessment. It's designed to ensure you graduate not just with textbook knowledge, but as a well-rounded, completely reliable lab practitioner ready to jump straight into a real-world team.
Now, if this structured learning path matches your career goals, the source material explicitly notes that seats are limited. For those ready to take action, the flyer directs you to their website at genomia.in, their support email, or their dedicated WhatsApp number to secure a spot and get registered.
So we've seen the full chronological journey laid out in this module. Knowing the massive leap it takes to go from theoretical textbook biology to actually operating a live industrial fermenter and analyzing the real-world data, the only question left for you is, are you ready to scale up your own skills? Thanks so much for joining me on this explainer, and keep learning.